Okay, so as soon as you see this drop factor here, what are the three things that you know you need to solve this problem? Don't be shy.
Need to know the drip factor for how long and what's being administered, the amount.
Okay, so I just want you to get used to saying when I do this problem, I know I need my total volume, I need my total time in minutes, and I need my drop factor. Okay? So total volume here is what? And I want you to write this down because I'm going to go to the whiteboard. So what's your total volume here?
100 mLs,
Okay. And what is your time in minutes?
30 minutes.
And your drop factor is,
Okay.
and if you do this the same way every time, you won't have an issue. The only thing that you have to remember is if your time isn't already in minutes, if your volume isn't already in milliliters, or if your drop factor says PD or micro, okay? PD or micro is always going to be 60 for your drop factor. Otherwise, it's going to give you a macro drip, okay, which is going to usually be like 10, 15, 20, something like that. So we have 100 mLs total. That's our volume. And that's because I just know in my brain that it's total volume over total time in minutes. And this is just teaching you how do you know what to pull out of the problem. Times your drop factor. Nothing else in that problem matters. We got 30 minutes. And our drop factor here is 10. I already know that 30 will go into 100 3 point something times, right? And then I'm going to end up multiplying that answer by 10. So 100 divided by 30 gives me 3.3 times. And my drop factor equals 33.33. Now, what's the last part of this formula that we didn't write?
What we round into?
Okay, we always round it to a whole number. Even if it doesn't say it in the problem, it's a given. So you're expected to know this. This is a nursing rule. All right, so what's our answer going to be here?
33.
Yep. All right, everybody with me?
Yes.
Stop my share for a minute so I can grab another problem.
Where you going? Sure. Okay.
Okay, here we go. All right, you guys are going to do this one on your own. Take your time because not everybody can read fast. So remember what your formula is.
So, infuse over 24 hours.
Okay, so everybody should have read this part first, and by now you should have out of the problem what you need. Does everybody have out what they need?
Mm-hmm.
Okay, so we should have got 10.41 equals 10. Is that what we got?
Yeah.
Okay, here's the next one. Can you guys, what do you guys see?
The physician writes an order for heparin 2,900 units.
Okay. So again, this is asking you how many mLs per hour will be set for the pump to deliver the correct dose. So what is the formula for this?
This fire over half.
Desired over half. Now, here's the thing. What we don't have is we don't have the desired dose, right?
Right.
We know that we're supposed to deliver 2,900 units per hour, and we have so many units in there. So, oh, I'm sorry, I'm looking at this wrong. So this is desired over half when we do have the desired dose, and we have what we have ordered on hand, right? We have both of those things.
Yes.
Okay, so write those down because those are your givens.
All right, so 29 units per hour. 58.
So your desired dose is 29 units per hour. And what you have on hand is 5,800 units in 100 ml, right?
Mhm. 100
Okay,
ml.
so now let's go here, board, and it's just going to be desired over half.
Oh, excuse me.
Okay, remember our units is going to cross out, and then you just have the 2,900 divided by the 5,800. Times the 100. Okay, and that's what you should have ended up with. Everybody good with that one?
Yeah.
Yeah.
Okay, here's the next one. So this is asking how many units per hour the patient is receiving. So remember, for this one, you have to calculate how many units is in each ml, right?
Excuse
Now
me.
look at how the order is written. Your patient's receiving heparin at 48 mLs per hour. So if you know he's getting 48 mLs, then you have to calculate how many units is in each one of those mLs. All right. So what do you have on hand?
So 48 mLs per hour. Oh no, what we have on hand is the 5,000 units.
Right, per 100 mLs. So what you have to do is take your 5,000 and divide that by 100, right? And we know that it's running at 48 mLs per hour. So first step here is to calculate your units per ml. So you know that you have 5,000 units in 1,000 mLs, right?
Mm-hmm. No,
So
in
you're gonna,
100 mLs. The heparin
okay,
bag is 5,000 units and 100 mLs.
okay. So let's go back to that. So we have 5,000 units per 100 ml. So let's remove one of those zeros. Thank you. All right.
Mhm.
So now we're just going to take our 5,000 and divide it by 100. And that tells us that we have 50 units per ml. And our bag is running at 48 mLs an hour. So now we take our 50 units and multiply that times the mLs it's running per hour, which is 48. And that means our patient is getting 2,400 units.
Per hour.
Yes. Okay.
Okay.
Ms. Loach, can I see that question again? How is the question?
Hold on a second. Okay, can you see it?
Yes, I just got to do more of those.
Okay, so
Got it. Thank you.
I'm just going to a couple more of those so we can do them together. Oh, come on. Where you at, heparin? You guys see heparin practice dosage calc?
No, we still see
What do
the last question. Your
How about
Word
now?
document.
No.
No, still see the Word document.
How about now?
Yep, now we see it.
All right. So let's look at number 4. I'm going to make it bigger. This is the same kind of question. We'll do number 4 first, and then we'll go back to number 3.
Number 4.
Okay, can you see the question there?
Yes.
Okay, so questions asking how many units per hour is the client receiving, okay?
Mm-hmm.
So you have your given, which is your 10,000 units per 100 ml.
Take the 10,000.
And you know that the pump is running at 29 mLs per hour. Okay, so the first thing you have to do here is determine how many units in each ml. Okay, so you have 10,000 units per 100 ml, so you got to take 10,000 and divide that by your 100.
Okay, so you'll get 100 units per ml.
Okay, and you have it running at 29 mLs per hour.
So you'll times that by the 29. And you should get 2,900 units per hour.
Correct. You with me? Whoever was asking about the question?
Wait. Yes, thank you.
Here, let's do another one. We're going to do number 3. See if you can get the answer. Just read to yourself, please, so you don't mess anybody up, because everybody might not do it the same. And then when you're done, check yourself. See if the answer you got is up there.
My answer's up there.
How about everybody else? Anybody still working on it?
No, my answer's there.
All right, that's 2. 2 out of 10.
Yeah, mine's is up there.
Okay, so we're all good on this. Everybody should have gotten C here. Did everybody get C?
Yes.
Yes.
Okay, any questions on that?
No.
Okay. All right. Let's look at number 2. Now, when you look at number 2, all you're going to do is you're going to calculate the flow rate for the IV pump, okay? Now, we already talked about this. When you're calculating the flow rate for the IV pump in mLs per hour on one of these questions, what are the 2 things that you need? See, right here, it's telling you to calculate the flow rate, right? So what do you need? How did I tell you how to do these?
The total volume over the total minutes. Well,
That's only if you're just calculating, like let's say you have 100 mLs and you're giving that over 24 hours. But this here is asking you for a dose, right? This is asking you for a dose. That's why all this information is in this statement, right?
mm-hmm.
So if it's asking you for a dose, how are you going to set it up?
Desire over half.
Okay. And it gives you your desired, your what you have on hand right there, right? So what do you have on hand?
12,500 units per 250 mLs.
Okay, so now all you have to calculate is your desired dose, right? Because you have what you have on hand. That's given in the statement, right? So to calculate the desired dose on this, you need the weight, which is what?
198 pounds.
Okay. And you need your ordered dose. And what's your ordered dose?
16 units per kilogram per hour.
Very good. Okay, does anybody else see that there's nothing else that you need from this problem? Okay, those are the things that you need. You need the information that you need to calculate the desired dose, and you need what you have on hand. That bolus, that's not fluff, because if you were going to give this, you would have to give this before you can start your dose, because you're trying to titrate this up so that it's actually working in the body. Okay, but you don't need it to answer this question, but it's not fluff. Okay, so you don't need it because you're doing desired over have, and you have your what you have on hand in the question. It's already built there, and it gave you the information you need to calculate your desired dose. Okay, so let's go to the screen now. Okay, you know that you have 12,500 units per 250 ml. So we can put that here. We're trying to get to mLs per hour, because that's where we're going to set our pump to. And our ordered dose is 16 units per kilogram per hour. So we'll start with our weight, which is 198. Again, you're going to leave everything in the calculator. We're going to divide that by 2.2. And that gave us a weight of 90 kilograms. Our doctor ordered 16 units per kilogram per hour. And since we're ending up in milliliters per hour, we have units on hand. We don't have to do anything here. So 90 times 16 gives us 1440 units. And that's units per hour. Again, units here will cross out. You'll just do the math. I got 28.8. What'd you get?
28.8.
The same.
Oh, bam. The answer's there. Rock stars right there. Let's try another one. Again, we're just going to calculate the mLs per hour. We're not going to do the units for the IV bolus. It's not a big deal, but we're not going to do that right now because that's not going to be on the test. Okay. So it's asking you to calculate the mLs per hour. All right. So again, what are we going to start with? We have a given here. What is our given?
That we have on hand, heparin 25,000 units per 500 mLs.
Perfect. So we have 25,000 units per 500 mLs on hand. We have 18 units per kilogram per hour ordered. And the only other thing we need here is our weight, right?
Mm-hmm.
And that is 172 pounds. So on the bottom, I'm going to write what we have on hand. Oh, it's 500. We know that we need to end up in mLs per hour. And I just put this down here because it reminds me if I need to convert something, it just keeps that in mind for me. For this problem, we don't, but you just have to be able to see that in the problem. And the reason why we don't here is because everything is already in units per kilogram per hour, and we're going to end up in mLs per hour. So we're good, right? So our weight is 172. We're going to divide that by our 2.2. That gave us 78.18. I'm leaving that whole thing in my calculator. And I'm going to multiply it times my 18 units. And that gave me 1407.27. And I will take that whole thing and divide it by what I have on hand. Don't erase anything from the calculator. Again, this is going to be units per hour. So units is going to cross out. And you'll be left up with milliliters per hour. Hey, did you end up with something that says 28.1 or 28.14?
Did I miss a step somewhere? I didn't get that one.
Go back and look.
Yes, I got that, Miss Loesch. 28
I
and
got
then 0.145.
Yeah, I
Okay,
got
and that
28.
would, if we were rounded it to the nearest tenth, that would round to 28.1.
Yes.
Yeah. Yes.
Okay, now if we go back to the answer key, 28.1 is right here. Okay. Really, this bolus dose is just a desire to ever have, guys. All you would do with this is take this and put it over this. And that's going to give you that answer number B or close to it. Sometimes she rounds a little funky on here than what I would do it, but again, it's heparin. So a lot of times what they'll do is they'll round the weight. And so sometimes that's why the answer might be off by a point or two if you're doing it on here versus what you're doing at the school. If I want you to round by the weight, we would tell you that. Okay, but not everybody does it that way, and that could be based on what your hospital facility policy is or something else.
Miss
All
Sue,
right. Yes.
will it be multiple choice like that, or would just
No, it will not be multiple choice. You will have to
Oh.
calculate the answer.
Okay.
This is just a program I use to practice with because she already has the practice here, so I don't have to invent questions. All right, let's look at some of these other ones. All right, let's start with number 2, and then we'll come back to the more difficult ones. All right, this is just asking you mLs per dose. So how are you going to set this up? Come on, nurse. When it's mLs per dose, how are you going to set it up?
Desired over half.
Okay, what's your desired dose? It already gave you that.
50.
50 units per kilogram.
Okay, and what do you have on hand?
5,000
5,000.
units.
Okay, so put what you have on hand on the bottom. And now you just have to calculate your desired dose, and it already gave you your weight in kilograms, so you don't have to do anything there except multiply. So you should have got this, right?
Mm-hmm.
And that should have been your final answer. Everybody get that?
Yes.
Yes.
Okay, and there it is. There's another one, number 4. This is going to be done the same way. If you just look at what you have in the problem, that tells you that this is going to be set up the same way. Okay. So what do you have on hand?
100 units per ml.
Okay, and then the next thing you just have to do is calculate your desired dose. Your weight is already in kilograms. Okay, so you should have ended up with 17.4.
Yes.
Okay, and there we have it. So how y'all feeling about those?
Good.
Now let's try it a little bit harder. Okay, let's do number 10. Now, the difference in this one is it's still asking you for mLs per hour, so it's still going to be desired over half here. Okay, what's your desired dose?
10 micrograms per kilogram.
Okay,
And we have on hand 500 milligrams per 500 mLs.
okay.
So we just got to change the weight from pounds to kilograms.
What
And
else do you have
convert.
to? Okay, and convert because your order is in micrograms
Oh, that's right.
and what you have on hand is in milligrams, right? And it's also ordered as kilograms per minute.
So you got to
So,
change your minutes into hour.
correct. So you're going to need your weight, and that's the first thing you're going to have to convert. So let's go to the board for this. Everybody got their numbers?
1 second. Okay, thank you.
Okay, so again, put down here on the bottom what you have on hand, which is 500 milligrams per 500 ml. You need mLs per hour. Okay, so 170 is your weight. So we're going to start with that 170. And we're going to divide by 2.2. Leave everything in the calculator. That should have gave you 77.27. And we're just going to put a line under that for infinity, okay? And leave everything in the calculator. Now we're going to multiply that times our desired dose, which is 10 micrograms. And that's going to give you 772.72 infinity. And that is going to be micrograms per minute. Okay, so we're going to divide by 1,000, and that's going to give us some milligrams. So you should end up with 0.772, blah, blah, blah. And that's milligrams per minute. Now we're going to multiply this by 60, okay, to give us 1 hour. And this times 60. And that should give you 46.36. Now your milligrams per hour. Milligrams is going to cross out here because you're going to divide that over what you have on hand. And you'll be left with mLs per hour. And you should end up with 46.36 because it's 500, 500, right?
Mm-hmm.
Now, if I told you to round this to the nearest tenth, what would it be?
46.4.
Okay, good. And is your answer up there?
Yep.
Okay, now we're going to go to number 1, and I'm going to have you guys try it. Okay, so here's number 1. So see if you can get one of those answers up there. Remember how to set the problem up and what do you need to take from the problem? So I was left with 21.6 milligrams per hour. That crossed out. I did the math. Okay, and I probably would have left it right there to the nearest tenth usually. Is everybody able to get to the 21.6?
Yes.
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 Okay, let's try another one. Number 3. Oh, wait a minute. It's 30, right? This is 30. Okay, so I think they just took this and they rounded it up probably to 61. On my test, I will tell you exactly where I want you to round it to, okay? Whether it's a whole number or the nearest tenth. On this one, because this was a 5, they just went ahead and rounded it, I believe, to the nearest whole number. Let's see what they did. Yeah, they rounded it to the nearest whole number. Okay, so you should have gotten 60.95 on that. If you didn't round it up to the whole number, I wouldn't have expected you to just known that. Was everybody able to get to the 60.95?
Yes.
Yes.
Yeah, I made a mistake somewhere.
Yes.
Okay, so let's go back and look at the steps to see where you made the mistake. So down here, I wrote the 4 milligrams per ml to start with, and up here, I took my weight, divided it by 2.2. All right, that gave me 135 kilograms, 0.45 infinity, left everything in the calculator. I multiplied that times my 30 micrograms per kilogram. Okay, and that gave me 4,063.63 micrograms per minute. Then I divided by 1,000 to convert this from micrograms to milligrams. And that gave me 4,000.63 milligrams per minute. I multiplied both sides by 60 to convert this to an hourly rate. All right, and then that gave me the 243.81. And then I divided that by my 4. All right, and milligrams crossed out here, and that left me with milliliters per hour for 60.95 milliliters per hour, or I rounded it up because the author rounded it up to 61. Did you see were you able to see where you made your error?
I don't do my math that way.
Okay.
Yeah, I have to figure it out because it's been working. I'm not sure why it's not working today for this problem anyway.
Okay. So, I mean, there's a couple of other ways that you can do it. I try to usually just stick with one method when I'm teaching, but you can do your conversions at any step of the game.
Right.
The main thing is that you have to keep everything in the calculator as you're doing it, because if you don't, if you change numbers or if you round stuff, that's going to mess up your final answer. That's the only thing you have to remember. Now, if you're doing dimensional analysis, of course, you're going to set this up entirely different.
Correct.
Let me just see something here.
Yeah, I
Um,
got 40.5. I'm not sure where. And I do my dimensional analysis way. I'm not sure why the answer is not there.
you're doing dimensional analysis, right? All right, let me just
Yes.
see something here. If you guys have your Abrams book or your dosage calc book registered, your L to R book registered on the point, you should be able to go in here and find some practice dosage calc questions. The only problem with these ones is they're not wordy the way that we word them. Let me see if I can find one that's similar to what we just did.
Oh, I think I see what my problem is.
Think you see it? All
Yeah.
right, this
So is how much is the weight? Is 298 or 198?
the weight was 298 for that problem.
Okay, that's where my mistake was. One time.
You wrote in the wrong.
Yes, I wrote in the wrong thing.
Okay.
One time.
So let's try this one here. This one will give us formula, dimensional analysis, all that.
Yep, that was the problem. It's 298.
Okay, so let's do this one. So this is the same thing, you just don't have all those words in it, okay? It's asking you for mLs per hour, all right? So,
I see the whiteboard.
oh, sorry. All right, everybody see this one?
Yes.
Again, this is from your Abrams book. If you go into your Abrams book at the point and under student resources, if you scratch that code off and entered it into the point, you can access these practice questions under student resources. All right, let's go back to that one. Here we are. Okay, you have everything you need.
No, not yet.
Now, the difference between this one and the ones we were doing is what? What do you
Gotta
see
convert.
different?
You gotta
You don't have,
convert
go ahead, you have to convert what?
the 1 gram to be able
Okay,
to
so you have to
to
convert that, but what don't you have to convert here?
The weight.
the weight.
Right. I'm gonna go to the whiteboard and just do it on there, and then we'll come back to the answer. I wanted us to round it to the nearest whole number. Is that what you guys got?
Yeah.
Yeah.
Okay, so I took the weight because it gave us the weight in kilograms, and I multiplied that times our desired dose, which was 2 micrograms per minute. That gave us 244, and that was micrograms per minute. I needed milligrams, so I divided it by 1,000, and they gave me 0.244 milligrams per minute. I multiplied both sides by 60 to convert it to an hourly rate. That gave me 14.64, which I divided by the 1,000 per 500, and it gave me 7.32, which I rounded to 7. Well, let's go back to our page, and let's see if we're rock stars or not. Oh, bam, we are. Okay, and these are the different formulas. So, dimensional analysis is probably down here at the bottom somewhere. There you go. So that's how you would be setting it up if you're doing dimensional analysis.
Yep.
Okay. So, and I'm just showing you this way because you can actually see it in your book if you need a little assistance. This is the reason why I don't do a dimensional because my brain cannot do all these steps. I like that keep it simple. Stupid math. If I do this, I'm going to set it up wrong and I'm going to get the wrong answer because I just can't remember all the steps. All right. But if you're good with this is how you should do it.
Ain't gonna bring down so much. I'm telling you. Stop calling me. Stop.
All right.
You're
Here's
fine.
the last one. Let's do the last
You're
one
fine.
here.
How about you get up in this chair?
Oh,
You want to get out of bed?
All right,
Somebody's on.
put
Well, then
whoever's
stop.
not on mute. Okay.
No. Honey. I know. She's just gonna worry me to death. She was fine a little bit ago.
Amanda, mute yourself.
Got it. All right. Okay. Let's see if we can do this one. Again, remember this has different steps. Each one may have different steps. So what you just got to look at is, what do I have on hand? What is my conversion? Does my conversion match what it's asking me for? Everybody got all their numbers? Okay, so I started with the weight, divided that by the 2.2. That gave me 70. And I multiplied that times my 12 micrograms per minute. That gave me 840 micrograms per minute. Now we're dividing by 1,000 in order to get milligrams per minute. So we divided by 1,000. That gave us 0.84 milligrams per minute. We had to multiply both sides by 60 to bring that to an hourly rate. So 60 times 0.84 gave me 50.4 milligrams per hour. The milligrams crosses out. We divide that by our 500 per 50 ml, and that gave me 5.04, which it's probably going to ask us for the whole number. which should be 5. Okay, did everybody get that?
Yes.
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 All right,
Yeah.
you guys are good. Now, did everybody get the dosage calc that little PowerPoint I sent out?
Last
Yes.
week? Yes.
Yeah. So if you
Yes.
open that up on that PowerPoint, you'll see the steps for reconstitution, the steps for the drip factor, the steps for mLs per hour, like for these ones here.
Yeah, I seen them. They're helpful.
Okay, so look at those because that's going to help you do. There shouldn't be anything in that packet that's not in that packet that's on your test.
Oh, okay.
It's pretty muchly all the same, but all you're going to get is the same exact test like you got last week. And for those of you that didn't get it last week, it's going to be the same thing we just did. So you have to calculate a simple input and output. The reconstitution one, and there's a reconstitution one and an INO one in that packet. The heparin ones that we went over today and the weight-based ones that we just did. Anything else that anybody is not sure of that we didn't go over?
Miss Sue, can you do a reconstitution one before we go?
Okay, so
'Cause I
let's
didn't
find
see that
a
one.
reconstitution one. Let's see if they have one on here. Let's just do this one real quick and then I'll find a reconstitution one. So this one's asking you for mLs per hour. Now, if you notice the difference between this one and the ones that you've seen, right? The only thing you have here that you could possibly use out of this is what? Because it's not asking you for a dose. It's just asking you how to set the pump here.
What was your question, Miss Sue?
I just want you to calculate this problem. I just want you to understand that on the other
Okay.
ones, when we were doing desired over have, you had a lot more information. Remember, in this one, all you have here is a couple of things. Okay, you have the total strength of the drug that's in the volume, and you have the time for the infusion, and you have the total volume. But you don't have enough information here to calculate a desired dose, right?
Mm-mm.
Because you don't have what you have on hand. So what I want you to just see when you're looking at the problem is this is just going to be your total volume over your total number in hours. So when you look at mLs per hour, because some of the mLs per hour, we do our desired dose over hand, but in those questions, you get what you have on hand. It's giving you that. Here, you don't see that information, right?
No.
So I want you to be able to recognize when you see one question to another, this one's just asking you for mLs per hour. It's not asking you to calculate a desired dose. So let me go to the other screen. We have a total volume here of 250, and our time is 90 minutes. Okay, so remember for these ones, it's a very simple calculation. You just need your total volume, which is 250. We don't have our time in an hourly rate, and it's asking us mLs per hour. So if your time's not in an hourly rate, then you have to convert it to an hourly rate, correct?
Mm-hmm.
Right.
So I do it like this. Bam, done.
Oh, I did it right.
Okay. You could take the 90 and divide it by 60 and figure out what fraction of an hour that it is also. But really, you could just make this step real simple. Either way, you're going to get the same answer. Because if you take 90 divided by 60, you're going to get 1.5 hours. So if you take 250 and divide it by 1.5, or if you take 250 divided by 90 and multiply it by 60, you should still get the same answer, which is 1.67, right? I mean, 167 even, because that's what it'll come out to. Or one, if they told you to round it to the nearest tenth, right? It would be 166.7. Because you should have got 166, the devil's number, 166.666. Right? That's what you should have got,
Mm-hmm.
no matter how you did it. Hey, we go with that one?
Yes.
See what this one asked us to round it to the nearest whole number, so we would have gave it a 167. Now, it's going to give you some other ways to do this, okay? I don't really care how you do it. Again, look at all the different ways you could do it. Did you get the right answer? Like, I don't need all that math. For me, I just want to do it the simplest way possible. Again, you have access to all this through either your Abrams or your Taylor's Fundamentals book. All right, let's find a reconstitution. Let me just pause my share for a minute and find a reconstitution for you to go over it real quick.
Mhm.
Okay. Can you see it? It says, let me resume the share. Everybody's able to see the question? Yes, no, maybe so?
Yes.
Doctor's order says.
Okay. So again, it's asking how many milliliters should you use to administer the dose, okay? So this is just a desired over have here. Okay. What do you have on hand? And usually on mine, I'll put a final concentration just so you know. For you, this is all you're going to get are these basic reconstitutions. Okay. When I go over with you or get a chance to get the more intense ones, then we'll do them, but that'll probably be more for med surg too. So for your exam, all you're going to get is something basic like this. Okay. So what are you going to use to solve this? Because this is just desired over have, right?
Mm-hmm. You just got to convert the micrograms
Yeah.
to milligrams.
Mhm.
All right. And all you're going to do is divide it by 1,000, right?
Mhm.
So that's going to
Mhm.
be 2. 2 divided by 2. So how many milliliters are you going to give here?
1.
1.
Okay. And these are all going to be the same. Again, this is in that package that I sent you guys. So you just have to remember whatever your final concentration is, that's what you have on hand. And you're going to take your desired dose over what you have on hand. That's all you're going to see on these for the reconstitution. Now, you'll see other problems, okay? Because if you're looking at practice out there like this one here, okay? This is telling you more steps, and you're not going to get these on your reconstitution right now because I haven't went over this with you, and I know that no one else has went over this with you. So don't get caught up in these because you're not going to get these on the exam. Okay?
Okay.
Let's try another one here. Let's just put this on my page. Are you able to see my page?
Yeah.
So this is just asking you how many milliliters you're going to administer here. I would just take that out, and this is how you're going to see the question. The only difference is going to say, this will say final. So again, you're going to do the same steps here. This is in micrograms. You're going to have to convert it. You may not get one in micrograms. It may be in milligrams. And that's where you just have to read the question. So if you were doing this, what would your answer be?
2. I think.
Yes, it's 2.
Yeah, I think it's 2
Okay.
mLs.
So you're good. Any other ones that you think you're not sure about? Okay, then that's it.